Hi, welcome to the Neuro Revision Lab, where we're going to be looking at atomic structure and the periodic table part 2. This time we're going to take a look at atomic structure, specifically the protons, neutrons and electrons. Make sure you've got your notebooks at the ready. There will be a lot of diagrams in this one. Things you're going to need to understand first will be the particle model and how to use a periodic table, which we covered in the previous video. You're going to be able to draw and label an atom, including its subatomic particles, and you're going to be able to recall the charge and relative mass for each subatomic particle. To get started, we've got some new keywords for you: atom, nucleus, shell, proton, neutron, and electron. Take a little bit of time to write these words down. Practice the spelling and sounding out the words. Listen carefully for how these words are used and then research their definitions later. Everything in the known universe is made up of atoms. There are over 119 different kinds, but they all subsist of the same three subatomic particles: protons, neutrons, and electrons. Here we have examples of carbon and neon and sodium. These are each different representations of different elements. Different publications will display them in slightly different ways, but the model is always the same: a nucleus in the center, shells on the outside, and electrons dotted around them. I'm going to show you a standard way of displaying this information. It would be useful if you use a pencil so that you can rub out any mistakes that you might make. Drawing these are essential to success in your GCSE. This is a helium atom. You can tell because it has 2 protons, so it's the second element on the periodic table. In the center, there is often a small cluster. This will be the nucleus. The red circles, labeled with a plus sign, are your protons. Protons carry a 1 plus charge, and in terms of relative mass, they weigh 1. Now, a quick aside here for relative mass: weighing subatomic particles is virtually impossible. So instead we use relative mass, which is the same as comparing against another subatomic particle. Helpfully, the standard which we weigh it against is simply a proton, so it is always A1. You'll notice that there are 2 other spheres which are not labelled. These are neutrons. Discovered by a man named James Chadwick, neutrons have no charge whatsoever. In fact, we didn't even know they were there until he discovered atoms were weighing relatively more than they were supposed to. So the relative mass for them is actually the same as a proton, simply 1. Now, round the edge is what we call a shell. There are 2 yellow electrons. Electrons carry a strong negative charge of -1, and relative to a proton, they weigh just 1/2000th, which we're not even sure of, as it's quite hard to find them. So in GCSE, we can also accept simply that they are very small. As we've already said, this is simply what a helium atom will look like, but most elements will look similar. They will just have more protons, more neutrons, or more electrons for us to draw. The trick is making sure we lay it out correctly, which we will cover in a later video called Electronic Structure. At this point, keeping things nice and simple, this is what your revision should look like. Take a little bit of time to correct it or improve it, because this is going to be something that you'll come back to multiple times in chemistry and also in some areas of physics. So it's important to record it correctly. All right, let's try a couple of common exam questions. This is what a carbon atom would look like. Looks pretty similar, right? What I'd like you to do is label each of the following on this atom. Sketch it into your books, spend a little bit of time on it, and you should label it with its nucleus, its shells, its protons, neutrons, and electrons. After that, complete the table below. Pause the video while you work, and we'll have the answers for you shortly. For more revision resources, tips, and helpful materials, please visit the NeuroLab store. Everything here is specifically selected or made for neurodivergent learners. And as an added bonus, each purchase supports the channel and allows us to keep producing video content. As usual, subscribe, like, and share to this channel and get your revisions sorted for GCSE. So hopefully you've labelled your carbon atom to look at least a little bit like this. If it isn't quite the same, take this time to correct it. The nucleus is always in the centre. The shells are the two circular orbits that go around the nucleus, and the protons are the positively marked subatomic particles in the centre, of which you can see 4 of them. But in carbon there would normally be 6. So there's 2 there on the other side that you potentially can't see. The neutrons are the red spheres that are not marked with anything because they are neutral. And the electrons are sitting on the orbits. Again, we'll do more with shells and electrons later when we talk about electronic structure. In order to complete your table, the physics never really changes. The protons are positive, so the charge is a +1. The relative mass is 1. Neutrons don't have a charge, so we simply put 0. And the relative mass is compared to a proton, so is 1. Electrons are a -1, and they are 1/2000th relatively mass, or just simply very small. If this video helped, then you'll really love our neurodivergent notebooks. They are designed according to established Cornell note-taking methods, have soft pastel colours to reduce eye strain, and are covered in lots of helpful prompts such as periodic tables and keyword banks. They make excellent accompaniments to EHC plans and can be used effectively in schools instead of an ordinary notebook, and are just as effective and helpful at home. Like and subscribe for weekly updates from the Neuro Revision Lab, and leave a comment below for any content you would like to see covered next time.